All right, for this problem, I'm looking at this one, and I can see that with x minus 2 in the denominator, in fact, square root of x minus 2, it is discontinuous at the number 2. So I want to write this one as the limit, as I'll use a letter. I'll use A. A approaches 2. Now I'm missing something here. We'll go back and fill that in a minute. The integral from A to 5, and I'm going to write the square root as to the 1/2. On the limit, I'm missing a little bitty piece. If the integrand, if the limits of integration go from 2 to 5, I'm going to have to approach 2 from the right side. So put a plus sign. If the interval is from 2 to 5, there's no way I could approach 2 from the left side of 2. So I'm going to write x minus 2 to the 1/2 as x minus 2 to the negative 1/2. Since it's in the denominator, I will move it up and write the negative exponent. This problem, this integration, is a U substitution. And you could, if you can do this without showing the formal U substitution, that's fine. If you show the formal U substitution, I'll show that. U equals x minus 2. So what is du? It's dx. Derivative of x minus 2 is dx. And at this point, I could change the limits of integration to match u. I could leave them as they are, and then I have to remember those are values for x. My preference is to leave them as they are. If you want to change these to match u, you can do that. What's the antiderivative of u to the negative 1/2? That's going to be u to the 1/2, negative 1/2 plus 1 over 1/2. Let me throw in this limit as a approaches 2 from the right. And we're going from a to 5. Again, those are values for x. So before I plug in the a and the 5, I have to go back and plug in x minus 2. So this would be the limit as a approaches 2 from the right of x minus 2 to the 1/2. And instead of over 1/2, what can I write? Times 2. Got that. Now I'm going from a to 5. And I'm back to x, so I can take off this reminder equals x equals x. I'll plug in the 5 and the a. The limit as a approaches 2 from the right of 2 times 5 minus 2 to the 1/2 minus 2 times a minus 2 to the 1/2. And at this point, I can, well, I know 5 minus 2 is 3, but now I can plug in the 2 right here. I'll get something that's okay, something that makes sense. Once I plug in the 2, I'm done with limit. This is 2 times 3 to the 1/2 minus 2 times 2 minus 2 to the 1/2. This part is 0, so the answer is 2 times 3 to the 1/2. You can leave it like that. You can write 2 times the square root of 3. And then converge or diverge? Converges.